Alright, so my name is Lisa Childress. There's my email address as well on the slide, so if you have any questions for me or you're having any problems with labs, we do have some optional labs that you can do every afternoon if you're interested in labs. So if you're working on the labs and you have a question or a problem, feel free to send me an email, lchildress@4js.com. And I'll be checking that email periodically throughout the afternoon, and I'll check it in the morning as well, just in case you've been working on them in the evenings and have sent me an email since I've closed up for the night. This is the Genero Language Basics class. We're going to start out with the course overview so that you'll have some idea what to expect for the next 5 sessions. The class is based on BDL 250, which is our latest and greatest general release of Genero. We'll also be talking about Genero Studio and working within Genero Studio, and that version will also be version 2.50. We'll talk a lot more about Genero Studio. That's our integrated development environment that you can use to do all your coding. It has a lot of nice development tools built into it that you might really appreciate. So we'll be talking about that in one of our chapters today, Chapter 2. So the objectives for this class is by the end of the class, by the end of the week, you should be able to use the Genero Studio development environment effectively. You should be able to read, write, debug, and compile basic BDL code that selects, adds, updates, and deletes data from a database. Notice the debug in there. We don't actually have a chapter on the debugger, but I will take the time, about the middle of the week sometime, to give you a quick demonstration of the Genero graphical debugger. It's one of the components of Genero Studio, and it makes learning about a complex application that perhaps you've inherited a lot easier to figure out exactly what that application does by exploring it with the debugger. And of course you can also use the debugger to debug applications that you're working on. So it kind of has double duty. It's a pretty useful tool. So I'll give you a demonstration of that a little later in the week, say about Wednesday or so that you'll have an idea how that works. I also have an optional lab for the debugger so that you can get in and really use it and explore an application with it to get more familiar with its options. You should be able to create a basic form and use it in your program for your user interface. You should be able to work with single tables in the database and master detail applications as well. So the master detail application info comes later in the week, Friday, I believe. Here's chapter by chapter for the class, and I'll give you a breakdown on the chapters I expect to do for each day. Of course, today we're working on Chapter 1 as we speak, the Genero Overview chapter, or it's coming up at least in this slide set. Chapter 2 is the Genero Studio Overview that I just mentioned a few seconds ago, and Chapter 3 is BDL Basics, where we talk about the very basics of a Genero BDL program. And those are the 3 chapters that we'll cover today. So tomorrow, when we come in, we'll review, if you'd like a review, if you have any questions about any of the topics that we covered today. We can talk about the lab tomorrow morning, and if any of you work on the optional labs. And then we'll start in on Chapter 4, working with databases. So working with databases comes tomorrow, first thing. Chapter 5, we'll talk about the user interface. And Chapter 6, forms, which is also, of course, a big part of the user interface. So that's the plan for Tuesday, those 4, 5, and 6, those 3 chapters. And then on Wednesday, we'll talk about searching the database using something called Query by Example. We'll talk about enhancing the form, and then inserting, updating, and deleting database data in the Modifying Data chapter. Then we've got Arrays, Chapter 10, Managing Master Detail Forms, and Built-in Classes. Now I'm not exactly sure whether on Thursday we'll do 3 chapters or 2 chapters. I usually just wait to see how far along we get, how many questions you have, and that type of thing. So we play it by ear a bit on the last few days. But on Friday we may just end up with Chapter 11 and 12, Managing Master Detail Forms and the Built-in Classes chapter. We'll just see how it goes. So that's the chapters. We have 12 chapters to get through this week. So as I mentioned, most days we'll meet for about 2 to 2.5 hours. It may vary. We may get out a bit early, 2 hours, and some days we may run a little bit long. But I doubt that we'll run longer than 2.5 hours any day of the week this week. And there's our modules for the day. The general overview. When we finish the overview, if it looks like we've been working about an hour or so, we'll take a break. Otherwise, we'll go ahead and look at Module 2 and then take a break. We'll see where we end up there. And then we'll finish with Module 3, the BDL Basics. So that break may not be at the end of Module 2. If Module 1 takes about an hour, we may break before Module 2. So during the training session, we're doing an online class, as you know, so it won't bother anyone if you leave and come back and rejoin. You can do that at any time. And I've already mentioned a few times that if you need to reach me, you can send me an email, or you can use the chat interface in the Go to Training control panel. Either way works just fine. But if you do run across something after the session is over that you have a question about, you might prefer the email option instead of waiting till tomorrow. Here's the Go to Training interface that you're looking at right now, and here's the control panel over here on the right-hand side. I have a better screenshot of that control panel, so let me pop over to that. Here's a bigger picture of the control panel so you can look at it without having to squint your eyes. So here we've got the control panel open and close button. That arrow just closes up the control panel so that it doesn't use as much of your screen real estate. You have the option of choosing between telephone or mic and speakers with this icon, the speaker icon. I notice some of you are using telephone today and some of you are using mic and speakers. It looks like it's pretty evenly divided. If you have problems with audio, you can actually switch to telephone in the middle of the session if you need to. And if you click on that telephone option up there, the radio button, it will give you a phone number that you can use to call in. Sometimes that happens during a session. Down here's the chat interface that I was mentioning earlier, that you can use to send me a message during the session if you like, or a question that you might have. I may defer some of the questions again until after the session is finished, just to have a nice flow for the session. And right here, if you can see it above the chat interface, is the raise hand icon that you can use to get my attention. If you use the raise hand icon, I'll probably unmute you so that you can ask me a question in person. All right, so that puts us right here to the very first module, Module 1, the Genero overview. So I'm going to go ahead and pop right in here and start covering the chapter. If you have any questions, again, feel free to send me a question in the chat interface. I'll check it out and get you an answer. So this class is all about Genero VDL, our Business Development Language. That's what the BDL stands for. BDL is designed for business applications, applications that typically have a lot of screens and reports, a lot of reusable code like queries, database maintenance type of code. And typically, business applications interface with databases, have interaction with databases. So BDL is designed specifically for this type of an application. It's very easy to learn. It's very English-like. People usually pick up on it very quickly and come up to speed on it very quickly, with the end result that development with BDL is usually much faster than development with some of the 3GL tools or OO-oriented technologies. Typically, development is faster and has a lower error rate than with some of those other technologies. It's also very portable. One of the things we'll focus on in this chapter is the portability of the Genero application and front end. The reason that it's so portable, as we'll talk more about, is because it's based on XML. The entire front end, the user interface, is based on XML, which is, of course, very portable. We have flexible deployment. We can send this raw data and this XML-based user interface, or the components of the user interface, to just about any operating system or any front end without having to do anything to the code or even recompile to be able to do it. So very flexible deployment, and we'll talk about that in great detail in this chapter. We talked about coming up to speed on Genero BDL very quickly, the low error rate with Genero BDL, and it's really hard to pin down productivity with a development product. It's not like doing a benchmark with a database application. So benchmarking application development environments is a little harder. One of our customers, though, a large customer, used a Carnegie Mellon engineering methodology and was able, with that tool or that methodology, to measure the productivity of several of their development teams across multiple projects using a variety of tools that you see here, like Java, C++, and so on. And this is the results that they came up with. So notice the productivity numbers here. Genero comes out way ahead on the number of lines of code per hour. Looks like almost twice as much as with the other methodologies compared to C++ and Java and .NET. Almost twice as much productivity or lines of code per hour. But at the same time, notice that the error rate for the Genero code is much lower than with the other application tools. So that looks like, what, 75 to maybe 90% fewer bugs than the other 3GL languages or OO technologies. So that's what they found at a particular large customer of ours. Just to give you an idea, it is very fast and easy to learn, rapid productivity, and at the same time, very few bugs. Now, Genero is not considered a 3GL tool. It's not considered really to be an object-oriented tool, but it does have some extensions and built-in classes that provide all of those technologies. So that's one of the really nice things about it. So it includes a set of built-in classes that you can use to interface with programs, files, pipes, and strings. You can use methods to manipulate the user interface at runtime dynamically. There's methods to read and write XML and manipulate objects in the DOM tree. So it actually does provide object-oriented technology for folks that want to use it or need it. We also provide some utility functions and extensions. What they mean by utility functions is that these are functions that come in a separate library. So you actually have to import these in your BDL program to be able to use them. But we do provide them, so they're provided separate libraries. You can use utility functions to do things like display interactive message boxes without having to actually build the code yourself. Certainly you could code it yourself, but these are handy and quick and easy to use. There's database utility functions there that you can use to do database functions without having to write them yourself. For example, there's options in there to find out what type of database you're working with and work with transactions. We have C extensions that allow you to integrate your own C libraries if you want to, and integrate those with your BDL application. So if you've got some legacy C code out there, you can still use that with BDL. Java interface, right? We have a Java interface, or a Java bridge, we call it sometimes, that allows you to import Java classes, which you can then instantiate in your BDL program. So if you're a Java programmer, you have access to all these many Java classes that you can use and instantiate right there in your BDL program. There is a util.json class, if you're familiar with JSON, that provides an interface to convert program variable values to and from JSON data, a JSON string. So if you're familiar with JSON or want to use JSON, that's supported as well. We have a special class just for that, part of the util package. So speaking of JSON, if you're not that familiar with it, JSON stands for JavaScript Object Notation. It's hard to say. JavaScript Object Notation. It's a lightweight data interchange format for JavaScript. The idea there is it's become kind of a standard notation to parse and serialize data objects, to store and transmit data back and forth between disparate systems. It's text, so it's easy to read and write. They're saying it's an efficient alternative to XML for inter-process communications. For one thing, it's easier to read than XML. It's shorter than XML. So it's easier for us to use and program in, and it's easier for the system to process because of that. And it's become the standard, so all modern languages embed JSON parsing and serialization. There's a list of development tools there that embed JSON parsing and serialization or support it. And notice that now Genero 250 has been added to that list. So that's a enhancement or a feature of Genero 250. And a minute ago, we saw the util package is what we use to provide JSON classes that you can use to manipulate JSON objects. So you can use class methods to handle JSON objects or arrays, and class methods to convert program variables to and from a JSON string. We also support web component integration. So web component integration allows you to integrate a lot of third-party graphical components into your BDL program. So here it's saying you can enrich your applications with existing commercial or free web components. Some of them, of course, there's a charge for. Some of them are free. So you have to be a bit careful about going out there and looking for web components, because some of them, of course, do require licensing. But you can use charts, maps, execute actions with them. Basically, the web components are integrated with Genero BDL as a form object, a form widget called a web component widget. So you actually integrate the web component into the form as a widget, and then Genero communicates with the web component using a script, an interface script. And once you have the web component widget configured in the form, that has properties associated with it that describe the widget and the how to communicate with the widget, and then you just interact with the widget in a dialogue to use it. Interact with the web component widget to use it. So it's fairly straightforward. There's about 3 steps that you use to integrate a web component. We actually have a chapter on working with web components in the user interface class. So if you take the user interface class, next time we offer it, the very last chapter, if I remember right, discusses working with web components. And finally, the Web Services Extension. Genero provides a Web Services Extension so that you can work with web services. It provides everything you need to be able to be a web services provider or consumer. So web services are based on SOA, the service-oriented architecture. It's just a set of principles and methodologies that let you connect disparate systems, unlike systems, and exchange data between them. Web services is how you implement these SOA-defined services. And the idea is platform neutral. It doesn't matter what type of platform is talking to what other type of platform. And then you work with either a server that exposes or provides a service, or you have a client that consumes services. And Genero supports either one. We have everything you need to be the server or the consumer in a web services application. We even have a wizard that you can use to help you implement your web services. So that was a bit about the technologies that we support or integrate with Genero BDL. And this next section talks more about the architecture and something called the abstract user interface. This addresses the portability bullet that we saw earlier on, why Genero is so portable. So the heart of the Genero architecture is something called the DVM, this component right here in the middle. DVM stands for Dynamic Virtual Machine. Sometimes it's also called a runtime system. But the DVM is referring to almost a mini operating system that gets launched whenever you launch a program. So it creates an environment for running your program that's very similar to a mini operating system. It has all the information that's needed for your application to be able to connect to a database and interact with a database, access to web services. It also has any information needed about the front end and is able to communicate with the front end. So when it communicates with the front end, whether it's a desktop client or a web client, the DVM is essentially sending raw data to the front end as well as XML-based information about the front end. XML nodes, for lack of a better word, that make up all the components of your front end. Now refer to that as the abstract user interface. It's XML, so it's very portable, and it really doesn't matter if you look at the screenshot here what operating system you're using or what database you're using or what you're interfacing with. This DVM has all the information it needs to be able to communicate with any component of the application. One of the other benefits to Genero BDL is something called ODI, or the Open Database Interface. And that's what lets you write a program and embed SQL and be able to communicate with just about any database on the market without having to change the code. This Open Database Interface actually maps the SQL that you have embedded in your BDL program to the database that you're connecting to. And it will even translate a lot of, let's say, proprietary SQL statements to something that the database you're connected to understands. I know a lot of folks that work with Genero BDL come from an Informix environment. So sometimes folks that have been traditionally in an Informix environment working with an Informix database have some Informix specific or proprietary SQL statements in their code. Most of those proprietary SQL statements are actually mapped or converted by the Open Database Interface, the ODI, if you have migrated or you're working with a different database. There's a few statements that are not translated or can't be translated, so you would have to update those, but very few. I can only think of like 2 different, and they're not even full statements, they're just maybe parts of a statement, or you could consider it maybe an attribute or a parameter of a statement. So almost everything is translated to whatever database you're working with this ODI interface. Now if you wanted to be sure whether a particular SQL statement that you thought might be proprietary is going to translate well to a database like, let's say, Oracle that you're migrating to, we actually provide an ODI guide for each database that's supported. So you can look in this ODI guide for Oracle or DB2 or whatever database you're going to be working with, and it will tell you any statements that don't translate well or won't be translated and that might actually throw an exception. But actually there are very few of them. It's surprising how few there are. So that's what they mean by database agnostic. We have this Open Database Interface that uses native drivers to communicate with the databases, and it does a lot of the mapping of even proprietary SQL statements over to the database that you're actually using or connecting to. So you don't have to change your code very much. If you end up migrating to a different database in your company, or perhaps just starting to use other databases from different vendors, most of the time you don't need to change your code at all. Here it's referring to the separation of business logic and the user interface. So that refers back to this whole idea of XML, and XML being very portable. So since we're using basically an abstract user interface tree that's built up of XML nodes, you just configure the front end you use rather than having to code for a specific front end. So front end that's been designed for a desktop model, like we see here, can run just as well in a browser. So we do have a desktop model. This would be probably a good place to talk about our front end options. It's called the Genero Desktop Client, or GDC. So GDC is actually software that you install on the client machine, and that gives you the option to run the desktop client. If you want to work with a browser or deliver the application to a browser, that's the software as a service model here. That's just saying we have a web client. The Genero Web Client, or GWC, delivers applications to any device, whether that's a desktop machine where you're running Internet Explorer, or a mobile device like an iPhone, for example. Anything that supports a browser we can use with the Genero Web Client. So that's our two options for front ends: GDC, the Genero Desktop Client, and GWC, the Genero Web Client. Here's a picture of the Abstract User Interface Tree, or AUI tree. What this actually is a debug tree is what we call it. Let me just pop this up. You can see it live if you want to. This is an application. I'm in Genero Studio, which we'll talk a lot more about in a bit. I'm just going to run an application here called the Accounts application. Here it is. And I'm using the Genero Desktop Client. And if I just click on the, or hold down the Control key and right-click, let me get rid of that, that brings up what we call the debug tree. And it shows us all of the nodes in our abstract user interface. I'm going to bring up the application and put it right here beside it so that you can see. So all of these nodes in this abstract user interface tree are representing components of the user interface. And if you click on them, like I'm going to click on the form, notice that it shows you over here in the application screen that component that you're highlighting. So if I click on the window, it flashes and shows me that component. And each one of these are just XML nodes in the tree. So when you create, for example, a Genero form, and you compile that Genero form, it is compiled to XML. And then when that XML gets loaded into memory, that form just becomes essentially a node in the DOM tree, right, in the abstract user interface tree. It's kind of hard to say. So here's all the components. Here's a component of the form. It's a container called a grid container. Labels. All of those are just nodes in the tree, abstract user interface tree. So this works with just about any operating system. We support Windows, Mac, Linux. We support just about, any front end, right? The same application. Let me go ahead and close this since you've had a look at it. If I just close the application window, it'll go ahead and close the debug tree. So here I'm running on the desktop client, GDC. Notice down in the corner down here I can switch to the web client. And I can run that same application with the web client. Popped up over here on the other side. Let me shrink that down a bit. So there's the web client. Same application. You don't have to recompile or anything of that sort to run it on a different front end or even a different operating system. Oops. Go back to our desktop. All right, so I just wanted to show you that live. It's more interesting, I think, than just to see a screenshot of it. But that's the Abstract User Interface tree, or AUI tree. And you can see just right there on the screen, just consider that just a logical map of your user interface. It's got all the components, all the XML nodes from all the components that make up your user interface. All very portable. So here, just another view of the Abstract User Interface. What they're showing you here looks like a compiled form. Over here on the left is just a compiled form. And when we compile a form with Genero, it becomes XML. So it's an XML form. And we can display that XML form on any front end, any OS, because it's portable. So it has just a level of abstraction, right? This XML provides a level of abstraction above all the different layers. So here's a good screenshot, I believe, or a good picture that shows you all the different platforms and databases that are covered by Genero BDL or Genero. All the different flavors of operating systems, all the different flavors of databases, all the different vendors there are covered. This is also a good architecture slide because it shows us another component of the architecture we haven't talked about yet called the GAS, or the Genero Application Server. The Genero Application Server is used with the Genero Web Client. It actually provides the Genero Web Client. When you install the GAS, that gives you access to the Genero Web Client. It's a component of the GAS. But you can also use, as you can see, the GAS to deliver desktop client to the desktop client as well. So the GAS is just responsible for delivering Genero applications. For application requests that come in over the internet, of course, it requires a web server. A web server is required for deployment when you use GAS, but there's an option whenever you're actually in development mode where you can just use a direct connect to what we call the GAS standalone. But a web server is required with the GAS for deployment. All right, so that takes care of the first chapter. It's only about 40 minutes in or so. So I don't think we ought to take a break just yet. We'll go ahead and look at the second chapter, which is on Genero Studio. All right, looks like I have one question, but it's to the presenter only, so I'll hold off until the break, and then I'll answer the question at the break. All right, so let's go ahead and look at Chapter 2. One second while I go ahead and pop that up. And Chapter 2 is on Genero Studio. There we go. Just wanted to make sure I had some different settings the other day, so I just wanted to make sure. All right, so take a look here at Module 2, Genero Studio Overview. There we go. Genero Studio is our graphical integrated development environment. That's a mouthful, so I had to say it slow. But you can see there's a lot of components that make up Genero Studio, a lot of tools, a lot of development tools that are there. We won't be able to touch on all of them this week. There's a lot of different tools, but we will touch on several of them. For example, we will be working in this class with 2 or 3 of the components extensively. Code Editor, which is our editing tool, our text editing tool for Genero Studio. We'll be working some with Form Designer, our graphical form designer tool that you can use to create Genero forms. I'll introduce the graphical debugger to you later on in the week so that you can get an idea of how that works and how to use it. We'll use the project view extensively in this class because we'll be working in Genero Studio, and that's how you work with projects in Genero Studio, is through the project view. We won't have time to get into the Genero Application Generator, or Business Application Generator it's called, or BAM for short. Business Application Modeler, that's the BAM, sorry. We won't have time to get into Report Designer. We do have special classes just for Report Designer. It's an extensive product with a lot of features and options. I mentioned earlier that for web services, we actually have a wizard that will help you configure your web services. So that's referring to the wizard. It does have embedded source control in it. So that's what we're talking about here with this Teamwork SCM. It supports SVN for version control. There's a built-in profiler, and I'll probably have time to show you the profiler when I show you the graphical debugger later this week. I'll combine the two. There's a centralized database metaschema that you can use to enrich your database metaschema. We'll talk a lot more about that tomorrow. Allows us to work with databases without having to connect to the database every time we get ready to make a change to an application or work with an application. And then we have an integrated diff tool in Genero Studio, and I'll try to show you that today as well when we're looking at Code Editor. It's a handy tool for being able to tell what you've changed and what's different from the original or a separate file that's stored out there. So a lot of components with Genero Studio. We don't have time to look at all of them this week, but we'll certainly look at, let's say, at least half of them. If you're going to use Studio, probably the first thing you need to do is determine how you'll use it before you install it. It has 2 modes. There's a local or standalone mode that you'll use if you want to use Genero, let's say on your desktop machine or your laptop machine, as a standalone development environment. So you can do all your development right there locally on your own machine. So that's one mode. They call it local or standalone mode. That has a few other options. Not everything has to be local, but at least all the Genero suite of tools is on your local machine. There's also a remote mode, or client-server mode, that you can use, the second option down here. And that's where you have a Genero Studio server on a remote system, and then you have a Genero Studio client on your local system. And of course, from your client Studio server installation, you're accessing this remote Studio server. And the idea with the client-server mode is that you're typically working with a team, and that facilitates working with a team easier than, of course, the local or standalone mode. So working in a remote mode, you've got your Genero installation on a remote server. Typically the project files are on the remote server, or they can even be on yet another server, and even perhaps the database and the database client are on the remote server. Again, there's several options, several different ways you can configure it, but that's the general idea. Local, almost everything is on your local machine. Maybe everything is on your local machine. And with remote, most of your Genero tools are on a remote server, and you're accessing that remote server through a Studio client to do your development. So here's a screenshot or some graphics showing you what local mode can look like. Notice there's a couple of options even for local mode. The first one is pure standalone. Everything is on the local machine. So that would be Genero Studio, the Genero DVM, the runtime system that we talked about earlier in the previous chapter, the GDC, the Genero Desktop Client, or GWC, the web client. It's all being accessed locally, or is all on your local machine. The database and the database client. Everything can be local. So that would be a pure standalone local mode. You can also configure it a bit differently and still consider it to be local. For example, the database might be on a remote host. That would be pretty common, in fact, to have the database on a remote host. It's still considered a local mode for Studio Server, though, because you have all of your Studio components on your local machine. The project and source files can be on a separate machine. And then you have just configured access to the project and source files. So someone has configured, for example, a Samba share or a networked drive, and then you're accessing the project files through the share. So that's another possibility for local mode, and that would enable some sharing with other team members. So Studio local mode, all the Studio components are on a local machine. In Studio in remote mode, we mentioned that there's a Studio Server component that will be on a remote system, and then you'll be accessing that Genero Studio server with Genero Studio installed locally on your local machine. So it would be your Genero Studio client. You use an SSH connection, typically. That's what we recommend using to connect to the Studio server because it's more secure. And then here's our Studio clients accessing our remote components. And again, in this case, your Studio server is on the remote machine. Again, the database server could be on the same machine as Studio server, or it could be on a different machine, a database server. The same thing for the project files. They could be on the Genero Studio server, or they too could be on yet another machine that just has sharing configured via Samba or a networked file system of some sort of share. So there's our two modes for Genero Studio. You've got local mode and remote mode. For client options, a few minutes ago I was showing you the debug tree, and we looked at the debug tree. We started out with the GDC, the Genero Desktop Client, and then we switched over and used the Genero Web Client. And we could see that we could run the same application with both of those front ends without making any other changes. So that's what we're looking at here. We've got two different client options available in Studio. Right down here are our configurations. Let me go ahead and show you a bit more about those. We'll pop back into live again. So right down here at the bottom is where we see our desktop option for GDC. And if I select this wrench icon right here to the right, it brings up our Genero Configuration Management. And this is really where these configurations are set up, or where we can configure them. So right here is my desktop configuration that I'm using in Genero Studio, and right over here are all the environment sets for this configuration. So right here I've got all these options where I can specify the settings that I want to use while I'm working and developing. I've got options here for databases like Oracle, Postgres, Informix, of course, And notice by default, actually, Genero Studio installs with a SQLite configuration. So for class purposes and demo purposes, I'm just using this built-in configuration for SQLite. Now, of course, in a real environment, you can go in and configure the database that you want to work with. So if I had an Informix database that I'm trying to work with, I would set up an Informix configuration, right? Here's my environment set for Informix. Select that, and then here's my environment variables over here on the right for Informix, and I can go in and configure those and add them as I need them. There, that's better. So I could configure my Informix server, right, and specify my Informix server environment variable, my Informix dir, and so on, right here in this environment set dialog area. So that's my configuration for GDC, right, for my Genero desktop client. And then if I'm going to use the web client, I have a separate configuration for it. Same thing, I've got these environment sets over here that I can configure differently for when I use the Genero web client. And you can add configurations, right? If I had a remote configuration where I had Genero Studio server on another machine, I would go in and add with this plus symbol up here at the top. I could add all of my configuration information on my remote Genero Studio server and then configure my environment sets for it. Just wanted to pop in there and show you that because we don't specifically talk about that, if I remember correctly, anywhere else in the class, so I thought it would be worth taking a peek. All right, so there's your client options, and we looked some at how you actually configure those clients, the environment for the client configurations. So here a bit more about the Genero desktop client. The desktop client communicates with the DVM, the Dynamic Virtual Machine, one of three ways. There's a direct connect option where the DVM is on a remote host and GDC is going to start it with TCP or SSH, and again we recommend SSH for that. You can also configure a GAS connection. If you have GAS configured, the DVM is on a remote host and GDC will start it using the GAS, the application server. And then you can also use a local connection. So that's what I'm using, for example, for demo purposes, is because I've got a local studio environment and everything's on the same machine. So the DVM is on the same host and the GDC, the Genero desktop client, will start it as a local application. So you can configure the GDC, for example, if you have a remote connection, the DVM's on a remote host, you can connect to it or configure your connection to it from the Genero Tools menu option. You can bring up the desktop client there, or from the command line, GDC-A. And that will bring up the Genero desktop client so that you can configure the connection that you want. TCP, SSH, connection to GAS, or a local connection. The local connection is actually the default. So most of the time in a standalone environment like I have, usually those local connection defaults that are already there are just fine. So I haven't changed a single thing with my GDC configuration for this class. Everything's just as it was when I installed it. For GWC, to use the web client, you do have to configure the application server, what they call the GAS. So again, what I was just using when I demonstrated running the web client and the application came up in a browser is I was just using a local connection to what they call the standalone or the GAS standalone. So it's just a direct HTTP connection to the applications. So you can use that kind of standalone GAS connection or this HTTP dispatch connector during development. But then when you actually get ready to deploy an application with the GAS, it does require a web server. So it's just a handy thing for a developer to be able to use this local connection for development, but later for deployment, of course, you'll have to have a web server. This talks more about the standalone GAS for development or testing purposes. You don't have to have an actual web server. You can just use this HTTP connector with the GAS for testing and development purposes. And this is just going through a validation process. How do you know if that's going to work properly while I'm working with GAS development or application development with the GAS? So one way to test it is just to go ahead and start up what they call the GAS standalone connector, this HTTP dispatch, and you can do that from the command line or from a start menu. And then go ahead and bring up, for example, our demos. Just specify an application address and see if it connects properly and brings up the GWC correctly. So just to kind of demonstrate that, I'll go ahead and pop it up so you can see. I don't need Studio for that. So if I go over here and go to this Tools menu for my Genero Studio Start options here, here's this Genero Application Server Standalone. So I can fire that off just by selecting it, and now it's out there listening. And then I'm going to try providing this machine name and port number and make sure it connects okay. And I've actually got a shortcut configured for that, I think. There it is. So I don't have to do a lot of typing. And it should bring this up, right? This is our GAS demo page. Right down here you can see some of the demos. You should be able to bring that up. These are nice demos, by the way. This might be something you want to look at in any case, not just for testing the GAS standalone functionality. All right, so I just wanted to show that live. So that's how you can test, make sure that functionality to work with this, what they call the GAS standalone, is working okay. Now notice something else just to point out here real quick is whenever I worked outside of Genero Studio, I had to go over and, in the case of Windows here, I had to go and actually start that GAS standalone manually. They disappeared on me here. There they are. So I actually had to go out here and do it by clicking on this option for the application server standalone. If you're working inside of Studio, as we were a minute ago when we were looking at just demonstrating bringing up the web client, notice I didn't have to start the GAS standalone manually to do that. And the reason I didn't have to do that is because now with version 250 of Genero Studio, pop back in here into the web client, GWC, right down here where it says use GWC when I'm in my GWC configuration. If I click on the editing option there, notice right here it says GAS configuration details, use start script. So what's happened is that in Genero 250, in Genero Studio 250, they've added a convenience here where it actually starts up this GAS standalone. The actual name of it is HTTP dispatch. So that starts automatically if I'm working inside of Studio. Now, notice you can disable that, and then of course you would have to go out and manually start it like we just did. But that's one of the nice things about Studio is there's a lot of conveniences like that that keep you having to do a lot of things over and over that don't seem all that necessary sometimes. So now it's not necessary. You just kick it off automatically. Okay. So there's just validating the GAS startup, which is what we just went through a second ago, just accessing the demo page to make sure it comes up successfully. Now the rest of this chapter is just a tour of Studio. It might actually be better, again, if we just go live and do it live so that you're not looking at a bunch of screenshots. So let's do that. We'll just poke around here a bit in Genero Studio so you can see what's available. So I guess the first thing to start with would be this welcome page that comes up. So here's the welcome page, And there's a lot of tutorials and samples that come with your Genero Studio installation. So here's a bunch of samples and demos. This Office Store project, this is a sample project that's provided, was actually generated with the application generator that we talked about on, I guess it was the first page of the chapter, this BAM, Business Application Modeling tool. So it actually is generated from a model, a graphical model that you can create and design right here inside of Studio. So that's what this Office Store project is. It's generated code. It's good generated code, right? So we can use it for a lot of our demonstrations and whatnot for class purposes. So that's what I was actually running a few minutes ago, some generated code. I'm going to switch this back to the desktop client just because it's quicker. So there's a couple of applications with this Office Store demo project or sample project. There's the account application and the orders application. And this is a good place to explain a bit about the Genero Studio project view. This area over here on the left-hand side is called the project view, and this shows you your Genero projects. A project is just a logical view of all of the applications and application files that make up your project. So I can add files, for example, to an application here in the project view, but it's logical. And underneath the covers, it's not actually doing anything to these files. It's not moving them, for example, to a special project directory or anything like that. And as the same thing goes, I can delete a file here from my project, and I don't have to delete it from the disk. I can just delete it from this logical project view, right? But the actual file is still fine, and it's sitting out there on disk. Now there is an option to delete a file from disk, but it's just an option, right? So the project view is a logical view of all the files, programs, resource files, and so on that make up your given project. This Office Store.4pw up here at the top is what they call a .4pw, a project file. And it's an XML file actually underneath the covers that has all the information about all the nodes, all these nodes in my project. So it's keeping track of all the applications that I've created in this project, all the files and forms that make up an application, any libraries that I've added to an application, my database schema file that's added to my project. All of those things are tracked, mapped by the 4pw file, the project file. So that's what's at the very top of this project tree structure that you're looking at here. So within a project, you've got these different nodes. This is considered what they call a group node. It used to be called a project node. Nowadays we call it a group node. So this is a group of applications. You can think of it that way. Here is an application node. This is the accounts application node to run the accounts application. And then of course inside that application node are all the files that make up the account application. Again, this is generated code, so there's a few extra layers or a few extra nested nodes here that you don't always see or don't typically see with a project you create manually by hand or by yourself. These are libraries. The application flow, again, that's strictly for generated code. You have that library for that. Here's a database library that has information about our database schema file. And we'll talk more about the database schema file tomorrow. We have a database chapter tomorrow where we'll talk about that in detail. And then if you have any, typically these would be things like resource files, which again we'll learn more about later on this week. Resource files like presentation styles files, that type of thing. Sometimes you'll have libraries for external libraries that you need to use with your project. They're not actually part of the project per se. They're external modules, but you can link them in by adding them to libraries this way. So those are libraries. You can use them for various purposes, but the databases node is always a library node. And if you're working with a database, that's typically where you'll see your schema file for your database. And then down here is another application node for orders. So this particular project has two applications, accounts and orders, and these are the application nodes. Now inside the project view, you can compile files. Right, so if I right-click on a source file like a 4GL file, our source files with Genero end with a .4GL suffix, so I can right-click on a source file or a form file, which is what I've done here, and there's an option to compile it. So I can compile here. Right, there's a source file, order.4gl. I have the option to compile. So I can compile individual files here. But I also have, at the application level, I have the option to build or rebuild. Right? So if I select the build option, that will go ahead and do the compile and also the linking. If it's an application that has multiple modules in it, it will go ahead and compile and link them to create an executable. If I just execute an application inside of Studio, it will go ahead and do any building process as well. Again, one of those conveniences we talked about earlier that working with Studio gives you. You don't have to do everything one step at a time. A lot of times there will be options through a context menu or from a toolbar that actually do 2 or 3 things all together just to save you some time and energy. So that's what the execute does here. It does 2 or 3 functions. It compiles, links, and executes. All right, so that's the Office Store model. Let's see, if I go in a little bit more about project view here, I can create a new project, File, New, and that brings up all these different items here that I can pick from in a dialog. But I'm going to go to Genero Files, and there's an option here for Simple Project, and that's what I want unless I'm actually using the code generator. So there I've selected this new project option, and you can see now I have a project up here. This is going to be my .4pw up here at the top when I save it. And then down here I have a single group that gets created automatically for my applications. And then I have one application node, it's empty. A database library node here, again it's empty. And a library node for any libraries that I want to store there. Again, people use libraries for different purposes. Sometimes you'll see external entities there, like shared libraries, for example, will be there, external libraries. Sometimes you'll see resource files there. It's just a convenient place to put various components of your project so that you can organize them in a way that's easy to find things. So if I get ready to create a new application, there's several ways I can do it, but I can right-click right here on the application node. There's an option here for New File, Genero Files, and I can create a source file. There's the .4gl. Notice there's a lot of other options here for forms. Forms come in 2 styles, for lack of a better word. There's 2 different types of forms for the user interface with Genero. There are text-based forms, these .per files, which are legacy types of forms. And then there's the graphical form designer forms that you create using Form Designer graphically. And so they do have different extensions or different suffixes. So here I'm just going to create a source file, a .4gl. Wants to know where I want to save it. So I'll save it here. And you just give it a name. I'll call it test. Notice it's going to add that .4gl extension to it. So as soon as I create this source file, this gives us a chance to look at another Studio component called Code Editor. So over here on the right now, I've got this test4gl source file opened up in Code Editor. And it's there sitting there waiting for me to create a program. So I can just start typing. Hopefully I'm a better typer than I think I am. But main, I don't know, we'll just type in something silly, display hello world, and main. So there's a Genero program. It's as simple as that. We'll talk a whole lot more about that, of course, a bit later. We actually talk about writing a simple program today after Chapter 2. But there's a simple program that would actually execute and run, or it should, unless I have some syntax errors. And then something to show you about Code Editor that's kind of neat. Let's say I want to go in and add something else to this program now. There's an option for templates, they call them. If you select Control-T, it brings up this dialog where you can select a template, which are just some pre-configured snippets of code that you use pretty often, and again a convenience so that you don't have to type in the same stuff over and over. So let's say I'm going to create a function, just a simple function with no parameters. So I can select this option in my list of templates, and then it goes ahead and creates kind of the shell structure for a function for me. So there's my function. I'll give it a name, function test, in function. And then whatever I want to do in my function, of course, goes there. So it's pretty straightforward. Code Editor is a very simple, powerful tool. We'll see more. I'll show you the slide on Code Editor so that you can see all the features and functionality for it. Now what we're looking at here with all this color coding is actually another integrated tool called the diff tool. So if I click this option right up here, also there's a menu option, diff up here, normal view, and then over here, here's the same option in the toolbar. If I click that, I'm no longer doing what we'd call a diff, right? The differential or program differences. But I can compare two programs, again, with this diff menu where I can select a file that I want to use to compare what I'm actually editing in Code Editor with another file sitting out on disk. And they refer to that as the base file. Now in this case, I just created a file from scratch, right? There is no base file that's already been created out there for this little test.4gl application. So the only diff I can do with it is to see the differences between when I started with this file, when I created it, and any changes that I make to it from here on out. The orange, it is color-coded, so the specific colors mean different things. If you see orange, it means that you've changed something, which makes sense. I'm sitting here typing in stuff, so it's showing up all the changes as orange. If I go in now later and delete something, save the file, go in and delete something, the deleted lines will show up as red. It's easier to see if I select this option, switch to two-pane diff mode. So if I saved the file, came in and deleted something, in my two-pane diff mode here, I would be able to see a red box over here in the gutter. I think they call this the gutter over here on the left-hand side, that's showing you where lines were deleted from the original. Now when you're using the diff, the base copy, in this case it would be the file over here, is a read-only copy. So I couldn't change anything over here on the left-hand side even if I wanted to. It won't let you. The changeable one, of course, is your current working copy over here on the right-hand side. So I can pop back and forth between these different modes. Here's single-pane diff mode, where I would be able to see my color-coded blocks if I was in single-pane diff mode. I just saved the file, so right now everything's clear. There's no color coding. But I can go in here and switch to single-pane, and it'll show me deleted blocks in red. And then I've got this two-pane diff mode, which I think is actually the easiest way to see differences in it. So now I've got a bunch of stuff over here on the left-hand side because I've saved the file. So this is my, what we'd call the base copy of the file, as it is when I saved it. And over here on the right-hand side is my working copy of the file. And this left-hand side over here again is read-only. So if I go here and try to delete something, which I'm trying to do now, it's just ignoring me. My cursor won't move and nothing gets deleted. But over here in the working copy, of course, I can delete things. Oops. You can add comments, by the way, in a BDL program. We'll probably see this later. But comments, you can use the dashes. We've also got curly brackets that you can use. We'll see all of this a bit later. So you can add comments, and of course it's ignored by BDL. So that's the diff tool. I'm sure we'll see more of that later as we go along. And this is Code Editor. And you can switch between these different diff modes even while you're working on an application. That's very handy if you're working on a complicated application and you've made some changes to it since you've started and all of a sudden things don't work anymore. I don't know if you've had that happen, but I certainly have. And it's very handy because you can switch back over to this diff mode right here in the menu and you can see exactly what you've changed. So let's say I've changed that. Let's say that caused my program to quit working, or I think it's caused it to quit working. I can actually just go through and find all these new changes by using the color codes. And there's an option down here, copy to write. That means whatever I had over here on the left-hand side when I started, or before the change, or in the base file, if I'm using a file stored on disk, I can go ahead and update my working copy so that it matches what's on the left-hand side. And that's very useful if you've done something in your application that broke it, for example. We'll call it function, oh no. So there's the green color coding that tells me that I've added something new since I started. Right, so that's a difference between this file and the base file, which in this case is my copy that I just started with a few minutes ago. So green means that I've added something. So again, if I'm not happy, things are broken, even though I'm working on the right-hand side, I still have the option to copy to write, which means that whatever is in the base version of the file, let's say in this case the one that was working, I can go change by change and click the copy to write. And notice it just removed that new function to make it like the old copy. So you can do that one change at a time. It doesn't change everything, just whatever you have selected when you pick that copy to write. So that's a very useful tool. It doesn't look that useful with this real simple program that we're working on here, but in a very complex program where you're all over the place changing this and changing that, it's very useful for being able to track the changes you've made since you started your session. All of them will be color-coded. There's even options to, let's see if you can see them here, previous difference, first difference, next difference, last difference. Right, so you can actually hop down between all these changes and it will go from one change you've made to the next change, which is very helpful in a really large source file, application file. All right, so that's a bit about Code Editor. That's a pretty good start, I think. All right, so let's pop back up in here and see if there's anything else we want to look at. Make sure I haven't forgotten anything important. So this is the welcome page that we were looking at, where we found the Office Store sample application that's generated by our BAM component of Genero Studio, the Business Application Modeling component. And you can see there's a lot of other samples and tutorials there that you might want to look at when you're working with Genero Studio and maybe working on something a bit more advanced than what we're working on this week. There's information about the Office Store sample. That's what we use for a lot of the examples in today's screenshots, for example, some of tomorrow's screenshots where I'm showing you snippets of code. A lot of those snippets of code came from this Office Store sample, just so you could see real-life applications examples in class. Here's the project view, which we talked about in detail. I think we've talked about most of this. We've talked about everything except the debug option. I'm going to hold off on the debug option, though, till about Wednesday, maybe Thursday, to talk about the debugger. But you can actually use the graphical debugger right there inside the project view is where you can actually start working with the debugger and launching the debugger. And we'll see that again later in the week. Here's something I didn't show you. Let me pop back in here and show you what they call the project component properties. It's never too late to show it to you. Let me go back in normal mode here and get out of this diff. So now we're no longer doing the diff. If you click on any node in your project view, let me drag this over where you can see it better, it shows you all the properties for the file or application that you're working with. So in this case, I have the source file highlighted, this test.4gl that I created a minute ago, and it's showing me the properties for it. The file path is one of the properties. Compiler options, anything that you want to pass to the compiler so that when it compiles the file, it will add these new compiler options, can be added here, right? You can click on that and add compiler options. If you want to exclude a file from being compiled, when you compile an application or, well, an application, you can exclude it here. You might exclude, for example, an external library from compilation. Exclude from linking. So if you don't want to have a file, perhaps it's just a reference file that you have in a library so that you can reference the file and look at it, but you don't want it to be linked in, you can exclude it from linking by selecting the checkbox here. So those are your properties, and every node in the tree has its own set of properties. Target directory, file path, and of course it depends on what node that you're clicking, what the properties will be. The properties are node specific. So that's the project component properties, just more information about a file, like where is this thing located on disk, and do I have any special compiler options that I need for it to use when it compiles the file. You can specify that all here. Now, there's also command line arguments for application nodes down here at the bottom. I didn't point that out, but this actually will pass the arguments that you specify to the program when it launches it. So if you can actually accept those command line arguments inside the application, but pass them from here in the properties. So that kind of the same thing, right, as running a program from the command line and passing it parameters, but here you specify it in the properties. So there's creating a new project, which we did. We didn't save our project, but we created it with this File, New, Simple Project option. One thing I haven't showed you yet is what they call the project build rules. Now, the project build rules define how Genero Studio is supposed to compile source files. And there's a lot of different types of files based on these file extensions that we've seen so far. Form files, source files, resource file extensions. It's telling Genero what you're supposed to do or what you want it to do to actually build or compile all these different types of files with these different extensions. And of course, form files would be built differently than a source file. Here's one way. If we go here to this Edit Build Rules option right here, we can take a look at them. So you can edit project build rules. There's a hierarchy for them. You can edit the build rules at the global level. So the build rules you define there, grab a highlighter here. Here's the global level. So if you had some build rules that you had created using this plus sign up here, you can create your own build rules. You can create them for global build rules, which means that they'll be used for any application, right, or any file. There are default build rules, which are already pre-configured build rules, and if you look at them, you can see that those are for your typical generic Genero file extensions, right, like form files, source files, and so on. And there's also project build rules, and you actually can get into the project build rules just by right-clicking like we did in the side of the project. And project build rules have a higher priority than, for example, global or default build rules. So the hierarchy would be project build rules would have the highest priority, so it will always look there for the rules to build a certain file. If there's nothing there that matches a particular file type, the extension for a file, then it will look for global build rules. If there's nothing there for that particular file type, then it goes back to the default build rules and looks for the build rules there. So typically the default build rules are fine, but you can actually create your own. You may have cases where you actually want to do that when you're working outside of just plain old Genero BDL. One second. So for example, you can actually add what they call languages to the build rules. Notice that recently Genero 250 has built-in build rules now for Java. So if you've decided that you want to import Java classes and use Java class methods embedded in your Genero applications, we've already got some build rules configured for those. Options for linking, execution, variables that you need to have set for a particular language that you're configuring. So Java has already been pre-configured, but you can certainly go in and may need to go in and configure, for example, variable settings for Java, build rules, link rules, and so on. But it's already built in. But let's say you had maybe another language that you were working with, for example, maybe C++. You could go out and add your own language, right, and maybe C++ here, and then you could go in and you'd have all these different build rule options that you could configure for, C++ or whatever language you wanted to add. So that makes it easier for you to integrate other languages that you're working with into your Genero project. That's the whole idea of these build rules and being able to add your own build rules. Now let's say that I was working with Java. Just one more step here to kind of go over. If I was, what I would probably do is add a library. Highlight my group here. There's a new library option. And then I might go in there and call it Java Lib, right? Java Library. And then make sure that I add all of my Java code to the Java library. And notice I don't have any Java code to show you. But one thing to notice is the application nodes and the library nodes all have a language property. So notice how the language on this new library, whoops, there it is, Java Lib, this new library, the language by default is Genero. So it's expecting any modules to be in that library to be BDL modules with a .4GL extension. But I can go in here, and of course I would change my language for this library to be Java. And that way it would know that when that library is compiled, it needs to use the build rules and linking rules and whatnot that are configured in that Java language that we saw a few minutes ago. So that's more or less how you would handle that if you needed to add anything for a specific language that you're working with. Oops, went the wrong, no I didn't, thought I went the wrong way. So there's the project build rules, and the hierarchy or priority of those rules, starting at the bottom, project, global, and default. More information about Code Editor that I was showing you a few minutes ago. It had the integrated diff that we saw and worked with a bit. So that's what we're seeing here, this screenshot. They're in the diff mode because we see that orange there. It's telling us that we've made a modification to a line there, and it's different from the base file that it started with. This is looking at account.4gl, which is a source file for that account application that we saw in the Office Store sample project a few minutes ago. So it's a generated file, and the generated files have what they call points and blocks added to them so that you can go in and make modifications to these generated source files. And that way, if you make them between these points and blocks, they don't get written over next time it compiles the source file. So that's the purpose. If you're looking at all those colored blocks and points, they're so that you can make modifications to generated code. The problem with making modifications to it is the next time you make some changes and compile the code, your changes get overwritten if you don't put them between these special points and blocks. So Code Editor then has coding assistance. If you go to the Edit option in the menu, there's an option there for auto completion. So it will actually kind of help complete things. If it can anticipate what you're getting ready to type in, it'll help you out. There's search and replace functionality, which I'm sure we'll see several times this week while we're working with programs. A smart indent. It keeps track of how you've indented, and in the next line it will automatically indent for you if you use the tab key. It has smart tabs for that. Color coding, which you see here. We've got the different colors that point out, for example, points and blocks in generated code are all color-coded. Text folding, which is nice for really large applications. You can fold it up so that you don't have to scroll up and down so much when you're trying to analyze some lines of codes and look further down in the application for where it's used again or where parameters are used again. Split windows, internationalization, bookmarks, syntax help. Right there's an example of syntax help. That red X tells us that there's a syntax problem, and if I click on the red X, it will actually give me a hint, some sort of syntax help, and tell me what's wrong. Sometimes it's very helpful, other times it's fairly generic. It just depends. XML editing is supported in Code Editor, and if you're let's say a Unix or Linux developer, it also supports VI if you prefer the VI editor. You can configure that in Code Editor, and from then on, instead of using the regular editor that we've been using here in class, it will use the VI editor. Code Editor Coding Assistance. I think I showed you this already. This is the set of templates that you can bring up automatically in Code Editor. If you hit like Control-T, it'll pop this up, and it creates a shell of our code snippet for commonly used statements in the code, so that you don't have to type everything in manually. Just a convenience for you. You can actually create your own templates as well. I believe it's in Tools Preferences. There's the template option there, Code Editor Template, if I remember correctly, and you can actually go in and add templates. If you use the same code several times or many times, you can go in and make your own template, and then it'll show up in this list when you do the Control-T. All right, so that wasn't too bad. We finished Chapter 1 and Chapter 2, the chapter on Genero Studio and the chapter on Genero Overview. So I think this is probably a good time for, let's say, a 10-minute break. So let's take a 10-minute break. That'll put us at 12:45 or 15 till the hour if you're not on Central Time. I'm on Central Time, so we'll just say 15 till the hour. Right. Enjoy your break, and I'll see you in a few moments. All right, my big fear is not showing the screen after I take a break because I always freeze the screen. So if you don't see the screen advance, let me know, or the PowerPoint slide advance, let me know. That would be the second time that I've done that this year. That would be bad. So Chapter 3 is our last chapter today. It's on BDL Basics. We're going to start looking at things like data types, and really you've already seen a lot of these things when we were tinkering around looking at code editors. So part of this you've already seen today, so it might be old hat. All right, so at the end of this module, we're going to be able to write, compile, and execute a simple BDL program, although I think you already know probably a lot of what we're going to look at in this chapter. Define and use variables and constants, and using other BDL data types effectively. Or use BDL data types effectively. So we'll take a look at the options you have when you're selecting data types. Just one second, I'm just going to take a peek here and make sure that my screen's showing. Okay, very good. Genero BDL conventions. So you probably noticed when we were looking at code editor and I was typing in little snippets of BDL source information, you probably noticed it's just plain old text, very human readable source code. You do write it in as text in a source module, and you already know from that demonstration earlier that it has to end with a .4GL extension. So that's what our source modules look like. Comments, we saw one comment there where we had the dashes, right? So you can use a pair of minus signs or dashes, whatever you want to call them, or you can use the pound symbol or hash symbol. I think some people call that the hash symbol. Curly braces can be used if you have lots of comments and they're going to occupy multiple lines. You can use the curly braces instead of putting the minus signs or the dashes on every line. So it's a bit of a shortcut. White space is treated as a single white space. So you can use all kinds of indentions and white space to make it easier for you to read and differentiate between functions and that type of thing, and it doesn't hurt a thing. So make it as readable as you need it to be. It's not case sensitive, but code editor, for example, will automatically put reserved words or keywords in uppercase, and that's just, I guess, to show you that they are reserved words or keywords, but it's not important as far as whether or not the program's going to work or not. So it's not case sensitive. You can use camel case, you can use all lowercase, all uppercase, whatever you prefer. For the snippets of code, notice that I usually do the same thing that code editor does, and I go ahead and put all of my keywords or reserved words in uppercase, just so that you as a student can see which words are keywords and which words are not. So it is a structured programming language. Executable statements have to be grouped into these program blocks or logical sections of code, however you want to think of those. And we have 3 different program blocks where you can type in your executable statements. There's the main program block, which of course is the one we typically start a program out with. Every application has to have a main with BDL. So we've got our main, then we have our function blocks where you can have these individual chunks of executable code out there that we call functions, and those are separate program blocks. They can even be in separate modules from the main if it's convenient for you to set them up that way. For example, that's the way a lot of people create libraries of reusable code, is that they'll create a library of functions that they know they're going to use over and over again in a separate module and basically create a library in that fashion. So functions can be in separate modules if you like. So a function is a program block, and then there's also a report block. And again, we're not going to get into reports in this class because it has a whole, I think it's 3 days long, if I remember right, a whole 3-day class just on reports. So this class will just strictly stick to BDL and the main and function program blocks. So here's a very simple example, and it's actually named simple.4gl. It has a main program block. It's not as simple as it could be because it also has an optional function program block, right? We don't have to have separate functions. We could just put everything in the main program block, but goodness, it would be hard for somebody to read, right? If it was a large program, a complex program, it would be very unreadable. So one of the big reasons that we have functions is for things like code reusability and also for readability and clarity. We'll have separate functions that do some sort of standalone, maybe not completely standalone, but a piece of code that achieves a specific purpose in a separate function for readability purposes. We've already looked at the compile and execute options when we were looking at Genero Studio earlier in the last chapter. So you've already seen the compile file option here on the right-hand side that you can use to compile a source file or a form file. There's a compile file option. That'll compile an individual file using the correct build rules for that type of file based on the extension. And then here's the build option that we talked about also in Chapter 2. That's a bit of a shortcut. It'll go ahead and compile and do the linking for you so that you have a runnable created by the build process. And then of course there's the execute option up here at the top that you can use to execute your application. And if you remember, the execute option also does some shortcuts as well. It'll go ahead and do any or it will try to compile and link applications as well as execute them. So a lot of shortcuts in Genero Studio versus working from the command line. Variables and constants. So if you've worked with other programming languages in the past, you're probably familiar with most or all of the terminology in this chapter, but it's worth going through just so you can see the differences between Genero's behavior and maybe other application development languages you've worked with. But variables, of course, hold data of a specific BDL data type, and these, of course, can change over time. You can change them, the values, programmatically. You have to declare variables with a special statement, the define statement. We've got some examples here on the slide. You can also use a shortcut, the like keyword, to declare a variable that has the same data type as a specific column in a database schema. And again, we'll go back to database schemas and learn more about databases tomorrow. That's the first chapter tomorrow. So here's an example, two examples, one of each that we just talked about. Here's defining a variable called actionNo, probably short for action number, and we're using a small int here for the data type. So there's a variable, and then here's another one where we've used this like keyword, and so we're defining a variable like the user ID column in the orders table of the database that we're connecting to. So that like is a bit of a shortcut there, so you don't have to go and look up the user ID column to see what data type it is, and what if the data type changes later in the table. This way, with the like keyword, your program variable is always going to have the same data type that the schema has. So that like keyword serves two purposes. And then down at the bottom, we've got a few bullets here about constants. If you're familiar with constants from another programming language, I'm sure it's the same here. So it works the same way. Constants are read-only values that you identify by a name. So this one, as an example, is the constant pi, is the name, pi. It's a decimal here that they've defined with a precision and a scale, 12 and 10. And then this is a constant value, 3.1415926. And that is not modifiable during the program execution, so cannot be programmatically changed. Hence the name constant, right? So constants are constant values. You can certainly use the values in arithmetic, that type of thing. Use them however you like, but you cannot modify them programmatically during the execution of the program. Now, one thing that we could have left off for a constant is the data definition here, the specification for it, the decimal, the data type, the 12, the precision, and the scale would automatically be picked up by the constant value. I had a hard time saying that, but hopefully you get the idea. All right, so you could actually just say constant pi equal 3 dot blah blah blah. You don't have to actually have the data type definition there. So that's one thing about constants that's a little bit different than defining a variable. Structured variables. So you can also, of course, use data structures to define variables. Arrays are records. An array, if you're familiar with arrays, hold groups of items that are all the same type. Records are an ordered set of variables where each member of the record can be any data type, or it can be another record, or it can be an array. So they're much more flexible than defining an array. So we have examples for both. We also have a bit more information about arrays here. We've got this array, A1, is a static array. See, it has a static size associated with it. So that's the largest size of this array. So that's a static array. This size is predefined. This one down here, the second example, this M product info array rec DB, is a dynamic array that has theoretically an unlimited size. It's based on memory and operating system and all of that good stuff. So a dynamic array does not have an implied or static size associated with it, whereas a static array, the first example, does. And then down here, the record, this ordered set of variables where each member can be any data type. So down here we're defining R1 as a record. Has 3 members, ID, which is defined as an integer, name, which is a varchar, and we'll look more at the actual data types themselves here in a moment, 50 bytes, and then end record. So there's a record. And once you've actually defined that record, you can, of course, use it just like you do any other variable. So here's the other way to define a record. Again, a shortcut where we're defining a record like a table in a database, the account table. So all the columns in the account table in this example are going to be used to define this record. So it'll have a member for each column in the account table, and each member will be defined like the column data type and size. So a shortcut there for working with databases. So that's structured data for variables. You can also define what they call user types. So user types means that essentially you're creating your own data type, and then once you've created your own user data type, you use them just as though they were normal data types, like the ones we've seen, integers, characters, whatever it happens to be. But these are typically complex structures. That's usually the reason you're creating them, is to more or less create yourself a shortcut. So we'll come back to this keyword public here in just a few minutes, but so right now just kind of focus on, here's a user type, rec account BR type. It's a record that we're creating, and these are all of the members of this user type. So we're actually creating a user type here that's going to be a special type of record. And then later on, we can use that, whoops, it's over here, use that special new user-defined data type to define variables. So here's mRec account lookup that's defined as this special public type rec account BR type. And it will have all of these members in it, account user ID, account email, and so on. So that's a user type. And we'll come back to the public keyword here in just a moment. When you're working with variables or constants, the scope can be either local, modular or module level scope are global. So local is fairly self-explanatory. I guess all of these are fairly self-explanatory, but local means that the variable is defined in a specific function or report or main program block. So the variable is defined in a program block, and it's only known and used inside that program block. The defined keyword has to precede any executable statements that you have in the program block. So that's a local scope. Modular scope, same basic idea, except this time it's confined to a specific module. So the variable can be set or used in any function, but it has to be within the single source code module. And this time the define, again, has to appear at the top of the module before any program blocks. So instead of being like inside of a function, this time the define has to be at the top before any of the functions. And then finally, global scope, talking about a variable or a constant that can be set or used in any function in any module of a multi-module program. And globals can be defined in a special globals file and imported from, and that file can be imported into your program to use it, or you can put it in a special global block, a special declaration block for globals as a globals keyword. We actually are kind of not recommending globals that much anymore. Here in a second we'll see more of a modular approach to, I'll say, reusing variables than what you have with globals, or referencing variables than what we have with globals. So globals are, I won't say frowned upon now, but they're discouraged these days. So people don't use globals as much. Local and modular are popular. So what we do instead of using globals, a more preferred method, uses more of a modular approach, or some people refer to it as encapsulation. It's making your program easier to read, more manageable, more controllable than using globals all over the place. So what you can do is specify, we saw that public keyword a minute ago, and what you can do instead is, typically when you're using globals because there is a function, possibly even in some other module, that you need to get information from or reference some way. So globals is a way of doing that, getting information across modules, so to speak. So what we're doing here is, instead of using globals, we're defining public variables. And you can actually import modules, external modules. Let's say it kind of goes back to that same idea of having a library of reusable code. So I've got these external modules, and I can import those into my program, into my application, and any variables in these external modules that are defined as public can be accessed or referenced in the importing module. That sounded really complicated, but I don't think it's as complicated as it sounds. So here we've got the import statement, right? We've got this import FGL that says we're importing a Genero module, and this is the name of the module. Here they're importing another one. And then inside of these modules that you're importing, if you want your application that's importing this module to be able to reference variables in one of the functions, or all the functions of the imported module, you need to have defined the variables as public. So that's all it is. The default behavior is private, right? Variables are defined as private by default. So if you use this public keyword, that means that a importing module can reference values in this function, or in this in this variable. I almost stumbled there, because you can actually define functions as public or private as well. Right? Same story there. Functions are private unless you define them as public. So I didn't mean to even mention that actually right right here. But that's okay. So anyway, that's kind of the idea. Instead of using globals, we're moving more to this style of thing, more encapsulating information within modules. And it makes it easier to read and a little more clear too, I think. Easier to read and more clarity. You can pass variables. So variable values can be passed as arguments to a function when you invoke it. You can pass it as pass a parameter as a variable, a literal, a constant, or even a valid expression. And if you have multiple arguments for a function, you can separate them by commas. So anytime you're defining a function, grab my highlighter here. Look at this example here. We're defining a variable called a phrase that's a string. We'll talk more about the data types and the sizes for them here in a few minutes. And then we're assigning hello world as the variable value here. And then we're calling a function called sayIt, and then we're passing this variable a phrase as a parameter to this function sayIt. So here's the function down here that we're invoking, function sayIt. Here it's showing that it's accepting a parameter defined as sayIt phrase, and down here's where we're defining sayIt phrase as a string variable, and then we're displaying sayIt phrase, which in this case will be the variable value for a phrase, hello world. So there's a function passing parameters to a function. In this case, we're passing variables, variable values. I think we're fairly close to the end. This is a fairly short chapter. So here we're just a few pages here on the different data types that we have with BDL. If you've been working with other programs in the past, it's always good to know exactly how something works, or how a specific data type works, and what's its minimum, maximum sizes, and that type of thing. Or just what data types are available is useful. So here we've got, of course, the usuals. We've got character, or char for short. Either syntax works just fine, which is a fixed size character string. The maximum size for a character, I believe, is about 64K. 65,534, in that range. I never can remember that exact number for some reason. Varchars are variable size character strings. You can associate a maximum size with them, and it's the same as a character. 65,535 or 534, whatever that value is, about 64K. Strings, on the other hand, are variable length, but they don't have a set maximum size like 64K. Instead, they're based on however much memory you have, kind of an OS or memory-specific thing, but there's no theoretical limit for strings. Date data types. We've got just plain old date, which is just a simple calendar date, but of course it doesn't actually store it like what we're accustomed to looking at when we have a date. It actually stores it as an integer value. It represents the number of days that have passed between December the 31st, 1899, I think. I think that's right? So 1899, December 31st. That's actually what gets stored in a date field, right? It's not actually the date, that looks like a date like we're accustomed to. For storage, it's actually an integer that represents the passing of however many days it's been since that special 1899 date. You can do math, arithmetic, with date fields, and of course the result will be as well an integer. So I can subtract two dates if I like. Date time is just more precise, right? You've got the idea here of a date and a time for a date time field. So the date and time, it goes all the way from the year to like fractions of a second. It can be very, very precise for date time. Interval actually can store spans of time, so you can do arithmetic on date time and store results, for example, in an interval. or just store a span of time in an interval, but typically it's used to store results of arithmetic, if I remember right. I haven't used an interval in a while. So trying to remember various things I've used intervals for. I believe just mainly arithmetic, but anything that's measured in a unit of time, age for somebody, time required for an activity, something like that. Seems like that's valid for interval. Boolean data types you're probably familiar with. Logical values, true or false, 0 or 1. So those are Booleans, usually used for testing results of something. Numeric data types, we've got big int, which is an 8-byte signed integer, which can be very, very large. I was trying to remember, I have no idea what the exact number is, but it's like over 9 billion, plus or minus 9 billion, I believe, or more than that, actually. So never mind, it's an 8-byte signed integer that is extremely large. Integer is 4-byte signed integer. I believe that's the one that actually is like 2 billion something, plus or minus 2 billion, but a very, very large signed integer. It goes all the way from integer to small int, which is a 2-byte signed integer, which is like 32K, 32,000 plus or minus. Tiny int, which is very small, it's like minus 128 or 127 to plus 127, so a very small numeric data type. So we have all the way from big int, which is very large. I probably couldn't even figure out how to tell you what the number is because it's got so many digits in it, all the way down to tiny int, which is just 127 is as big as it gets. We've got float and double precision. You can use those terms interchangeably, float or double precision. It's an 8-byte floating point decimal, so it is very precise values. So it's defined with a precision and a scale. The precisions are the numbers of significant digits that you have on the left-hand side, and the scale's the digits to the right. How many digits do you want to the right of the decimal point? So that's float. Can handle very large, very precise numbers. And then you have small float or real. Those are synonyms, which is a 4-byte floating point decimal. And then finally you've got decimal, numeric, or dec, right? Dec. You can use any of those. Any of that syntax will work, either of those three. High precision decimal. I think the limit on that is significant digits is 32. And traditionally the default is 16. So if you don't specify, I believe you get 16. And then for the scale, the numbers to the right of the decimal point, typically you get 2 if you don't specify. Money is just the same as decimal, except that it's formatable, right, for currency purposes. Large data types, we have byte and text, which is used to store large binary data for byte, things like images, JPEG, that type of thing. Text is used for large text data, just plain old text data, but typically very large files. So the last page here in the last chapter for today is just a diagram of some of the Genero file extensions that you'll get very comfortable with if you're not already comfortable with them. When we start working with other types of files, it's good to know what these extensions mean. So far we've looked at .4gl, right? That's an extension that we use for our source modules when we're writing BDL code. So that's our source file. When you compile a source file, it's compiled and receives a .42m extension. So that's a compiled source file. For forms, Remember earlier we talked about having two different types of forms. We have our old legacy type forms, which are just text-based forms, and those end with an extension of .per. So sometimes people just refer to those as per files for short, and that's our text-based forms. You just work on those with an editor by hand, right? Just plain old text. The other type of form file, though, is what we can develop graphically in Genero Studio Form Designer, and it ends with an extension of .4fd. So that's your Genero Studio Form Designer forms. It doesn't really matter, though, what kind of form that you prefer to work with. You can work with the old text-based forms, the .pers, or the 4fds in Form Designer. When you compile them, they both end up the same way. They end up as .42fs. And if you remember from earlier on, remember a compiled form is going to become a node in the abstract user interface tree. So it's compiled into XML. So it doesn't matter how it starts out, whether it's a form designer, graphically designed form file or a text file, it ends up as XML. And it ends up with an extension of .42f. And then finally, when we've done the compiling and the linking and we've created an executable from that build process, your actual executable or runnable is a .42r. I like the R because it's easy to remember, runnable. So that's just the basic Genero file extensions. There's a lot more types of files in the Genero environment, right? We've got all kinds of resource files that we'll be talking about later on this week. So there's the Genero file extensions for what we're working with for the first day or so. That's a good start. All right. So we finished our lecture for today. I was trying to think how we're doing on time today. So we started at 11. We're a little bit under 2 hours, or 2.5 hours, excuse me. So we didn't use all of our time, but it wasn't a very short day either, so it's just about right, I think. Now, one thing I wanted to tell you, let me go ahead and expand my control panel here, is that I have in your materials view,